in this video, we're going to talk about jet maxima that occur at low levels. And so most of the time that you've been studying meteorology, you've likely learned of a particular type of jet that we call the low-level jet. And I titled this section Jet Maxima at Low Levels because there are more than one type of what we might term a low-level jet. And so I want to help to solidify the difference between at least two of these. One is the classic low-level jet that we talk about that occurs around, say, 850 hectopascals, that has about a 30 meter per second maximum, and occurs primarily in the US, but it can occur all over the world. And our low-level jet here is the idea of a strengthened 850 millibar jet that has some topographic influences and generally transports large amounts of moisture northward, especially during convective weather seasons in the central Great Plains, that can fuel overnight MCS storms or feed into severe weather outbreaks. That's the concept of the low-level jet. There is another jet that occurs in the lower level that is really due to the nocturnal boundary layer wind maximum. And so this one we're going to call the nocturnal jet. The nocturnal jet occurs about 800 meters above ground level, or AGL. So maybe about halfway up to where we would otherwise indicate the low-level jet. And so this nocturnal boundary layer wind maximum occurs when the boundary layer decouples from the free atmosphere. This will act similarly to our low-level jet in that it can still transport Gulf moisture up in the Central Plains, but that the dynamics governing this are going to be different. This is where we get that fast wind just above the boundary layer when all of a sudden we free that part of the atmosphere from the higher friction values that are present in the boundary layer, and so that we speed up the wind just above this level, which can have large implications on what's happening just above ground level, feeding into storms, for example, or feeding advection to the north. This is slightly different in terms of dynamical causing from our low-level jet that is more large-scale forcings, whether through trough ridge systems or due to strong topographic influences. And so that it's important to consider that we have multiple low-level jet type features that are sometimes called different things. And there's a great paper about these phenomena by David Stentrud from 1996, and I encourage you to read that, as there is not strong, clear, consistent usage in our field of all of these different low-level jet terms. And it is something that we still struggle with and is sometimes confused when people are speaking what they think are the same things but are really two different things. That's it on low-level jets. Thanks for watching.